This audio clip that you're hearing now reminds me of days spent by the ocean. The ocean is the world's largest biome and takes up more space than land. About 71% of the Earth is comprised of water, with 97% of the water being contained in the ocean itself. Earth has 5 different oceans: the Pacific Ocean, the Indian Ocean, the Arctic Ocean, the Southern or Antarctic Ocean, and the Atlantic Ocean. Ocean water, like all water, cycles through the hydrological cycle. First, solar radiation causes ocean water to evaporate and float into the atmosphere as a gas. As this gas travels higher, it cools down and condenses into clouds. These clouds can then travel and will deposit water back into the ecosystems through precipitation. The ocean is divided into various levels. At the top is the littoral or intertidal zone, which is part of the shore and is frequently exposed to air. Next comes the neritic zone, which sits just behind the littoral zone where the ocean floor begins to dip and drop, increasing the water's depth. Next is the oceanic zone, which is subdivided into 5 zones based on depth. In order from top to bottom, these zones are the epipelagic, the mesopelagic, the bathypelagic, the abyssal, and the hadal zones. At the bottom of the ocean are the benthic and pelagic zones. The zones of the ocean differentiate by how much light they receive, their temperatures, density, and oxygen concentration. Upper zones receive the most solar radiation in the form of light, raising its temperature. Most solar radiation is absorbed within the first 10 meters of depth, and the remaining radiation is absorbed in the mesopelagic zone. Water is stratified thermally, meaning that warm water in the upper layers is kept mostly separate from the cold water of lower layers. Thermoclines act as a transitionary layer between warm and cold water, and water in thermoclines rapidly decrease in temperature as depth increases. In an ecosystem that receives such little solar radiation as the ocean, the organization of the food web and the trophic cascade and its influences on the transfer of energy is integral to sustaining organisms. In oceanic environments, primary producers such as aquatic plants and photosynthetic plankton absorb solar radiation. The primary consumers, such as zooplankton and small fish, then eat the primary producers. The secondary consumers, such as carnivorous fish and whales, eat the primary consumers, and then the tertiary consumers, such as sharks, eat the secondary consumers. Trophic cascades are often limited to a few levels because a majority of the gross primary production of energy is lost between the trophic levels. In other words, only a fraction of the energy in each trophic level, the net primary production, gets transferred to the higher level. Oxygen concentration also varies with depth. Ocean water contains a fraction of the amount of oxygen that air has, but different layers can contain more or less oxygen than others. The surface of the epipelagic, for example, where water comes into contact with air, contains the most oxygen, and concentration decreases with depth for the first 1,000 meters. Upon reaching the bathypelagic zone at 1,000 meters, oxygen concentration begins to increase again as the number of organisms using the water's oxygen begins to decrease with depth. One of the reasons why I was drawn so keenly to this audio clip is its inclusion of a whale song. I have a deep love for whales, and my family has a tradition of going whale watching in the Bay of Fundy at least once a year. By examining the behaviors and characteristics of whales, a demonstration of many topics covered in this course can be seen. For example, we can examine the life history traits of whales. Whales are case-selected, meaning that whales generally tend to have stable populations, and offspring tend to be few but well-reared. The focus is on securing the next generation, and generations tend to overlap. This is opposed to our selected species, which tend to produce many small offspring, with only a few surviving to maturity. Whales, which are idiroparous, tend to produce 1 or 2 calves at a time, taking great care in raising their young, and breed multiple times throughout their long lives. Whales' lifespans generally follow a type 1 survivorship curve, with the majority of deaths occurring later in life. The energetic trade-off between the number of offspring produced versus the size of offspring can also be seen in whales. There is usually a negative relationship between offspring size and number, and whales demonstrate this by their few but large calves. As for their distribution, whales tend to congregate in small groups called pods. They exhibit clump distribution. However, being so big, each subpopulation takes up a large amount of space. Whales are also eusocial, with members of different generations in the same pod working together to raise calves and to survive. The ocean has become extremely polluted with chemicals and garbage. Coral reefs are becoming bleached, fish are dying. Larger sea creatures such as whales, dolphins, and sharks are being struck by boats and being gravely, if not fatally, injured. The fishing industry steals innumerable fish from the ocean for profit, removing nutrients from the ecosystem that would otherwise be cycled back through. Overabundances of nutrients such as phosphorus and nitrogen are being put into the ocean through chemical dumping and have led to eutrophication of some areas, hypoxic dead zones. It is distressing and heartbreaking. As a society, we have put our interests into what profits ourselves most. What can make someone more money, or what can get someone ahead in life? This has led to people taking advantage of our natural resources for profit, to the point of destroying these ecosystems and driving species to extinction. This is why I appreciate the concept of two-eyed seeing, as it completely opposes these ideas. Instead of looking for what nature can do for us, two-eyed seeing looks at what we can do for nature, putting intrinsic worth into the environment. Two-eyed seeing emphasizes the interrelatedness of life. We rely on nature, and in turn, we have the ability to impact nature for better or for worse. However, our impact on nature will turn back and affect us as well, which we are now seeing in the impacts of climate change. If seeing ocean life imperiled due to human disturbance is not enough to enact change in our society for oceanic protection, maybe the impacts this is having and will have on humanity will help spur change.